we're asked to find the equivalent resistance, the voltage across the 10 ohm resistor and the current through the 10 ohm resistor. Now, first of all, I would like to show us that this is in series with this, which makes it 10. That means 6 plus 4 for series connection. You just add, that's 10 ohms. Now, that 10 ohm resistor is in parallel with this 10 ohm resistor, so that makes it 10 times 10 all over 10 plus 10. Okay, for parallel combination, that will give us 100 divided by 20, and 100 divided by 20 is simply 5 ohms. Okay, so now with this, the whole of this circuit is now reduced to this. You have your 7 here, and here you have your 5. Okay, then with your voltage source. Okay, so the total resistance now, Req, is going to be 7 plus 5, because it's series, which is equal to 12 ohm. So the equivalent resistance here is 12 ohms. Now, secondly, we're asked to find the voltage across the 10 ohm resistor. Okay, now I want to say this, that to find the voltage across the 10 ohm resistor, since the equivalent resistance is 12, we can first of all find the current, the total current in the circuit. So the total current is going to be V all over R. Okay, now your V, the total voltage is 24, the total resistance is 12. That gives us 2 amperes, so that makes it 2 amperes. So the total current is 2 amperes. Now, that current 2 amperes is actually what is supplied by this battery. So if this current is 2 amperes, it means that the current passing through this 7 ohm resistor is also 2 amperes. And the voltage across the 7 ohm resistor now, we can use IR, which is 2. The current is 2 times the resistance is 7. That makes it 14. So that means the voltage across the resistor is 14. What it means is that the voltage across the rest of this is 24 minus 14, because the 7 ohm resistor is in series with the whole of this. So 24 minus 14, which is equal to 10. Now, this 10 volts now is the voltage across this 10 ohm resistor, and it is also the voltage across both 6 ohm and 4 ohm combination resistor. Okay, so since the voltage across the 10 ohm resistor is also 10 volts, we can quickly find the current. Okay, that's the answer. That's what we asked to find, the voltage across the 10 ohm resistor. So the answer is simply 10 volts. Now, 10 volts because this is in parallel with this combination. Okay, so being in parallel means the same voltage is applied across them. Don't forget that whenever two resistors are in parallel, the same voltage is applied across them. Now, the next question is the current through the 10 ohm resistor. Since V is equal to IR, we can say that the I is equal to V over R. Now, the voltage is 10, the voltage across the 10 ohm resistor is 10, and the resistance is also 10. So that gives us 1 ampere. So that is the answer to that very question. Thank you.